Okay, I'm going to start the notes for sections 3.3 through 3.8. And so let's do that now. Problem 1, I want us to check if the numbers k equals -2 and k equals 3 are zeros for the function f of x equal 2x cubed plus x squared minus 11x minus 10. Okay, and then we're going to use the factor theorem to decide if x minus k is a factor of f of x for the given k value. Okay, so -2 needs to be plugged in for x. Okay, so if I do that, -2 cubed is -8 times 2 is -16. Plus 4 is -12. Plus 22 is 10. Minus 10 gives me 0. Okay, so because I'm getting 0 left over, then we say that k equals -2 is a 0 of f. Okay, a 0 is a number that's going to return 0. Now, knowing that -2 is a 0 means that x minus -2, or x plus 2, that's the same thing, that'd be a factor of f of x. Okay, so like if I were going to factor f of x, that would be, a degree 3 polynomial. And by the way, you guys are going to do lots of things with degree 3 and degree 4 polynomials coming up, and factoring in particular. But so I would already know one of the factors. It's x plus 2. Okay, and then now I'm checking if 3 is a factor. Okay, so same deal. We plug the number in. 3 cubed, 3 times 3 times 3, that's 27. Times 2 is 54. Plus 9 is 63. Minus 30 would be 30. Minus 10 is 20. Okay, so because I'm not getting 0, when I plug in 3, I would conclude that 3 is not a 0. Okay, and therefore x minus 3 would not be a factor of f. Okay, so as I said, if I were going to factor f of x, x plus 2 would be a factor, x minus 3 would not be a factor. Okay. Problem 2, the graph of a polynomial function f of x with leading coefficient a equals 1 and integer zeros is shown in the figure. Write the function in complete factored form. Okay, so whenever you know a 0, you know a corresponding factor. Okay, so the zeros here would be 2, -2, and -5. Now, knowing that -5 is a 0 means that x minus -5, or x plus 5, that'd be a factor. Knowing that -2 is a 0 means that x minus -2, or x plus 2, that'd be a factor. And then 2 is the third 0, so x minus 2 would be the third factor. Okay, and that'd be the answer. Problem 3 is a similar deal. So we have the graph of a polynomial that's shown. The leading coefficient is -3. That'd be the a value. And the integer zeros are shown below. So write f of x in complete factored form. Okay, so I'm going to have -3 times, and then just write these factors. So the zeros are -3, -1, 1, and 2. By the way, a 0 is the same thing as an x-intercept. Okay, so like that's all I'm doing here when I pick off the zeros. I'm picking off the x-intercepts, where this curve crosses the x-axis there. Okay, so knowing that -3 is a 0 means that x minus -3, or x plus 3, would be a factor. Knowing that -1 is a 0 means that x minus a -1, or x plus 1, that'd be a factor. 1 is a 0, so x minus 1 would be a factor. And 2 is a 0, so x minus 2 would be a factor. Okay, and I go ahead and circle that. Now problem 4 is the same thing as problems 2 and 3, although I don't have a graph. Okay, so they want us to find a polynomial of degree 3 whose zeros are negative 4, which has multiplicity 2, and 5, which has multiplicity 1. And we're going to write the answer in the form ax cubed plus bx squared plus cx plus d. Okay, so I'm looking for a degree 3 polynomial. I'm going to call this f of x. And the zeros are negative 2, which has multiplicity 2. So knowing that negative 4 is a 0, x minus negative 4 or x plus 4 would be a factor. Now that's a 0 of multiplicity 2. So that means that I can see negative 4 twice. Or x plus 4 times another x plus 4, that'd be x plus 4 squared. And 5 is a 0, which has multiplicity 1. So x minus 5 would be the third factor. Okay, and now I'm supposed to simplify this and write the answer in this form. So let's see, I got x plus 4 times x plus 4. That'd be x squared plus 8x plus 16 times x minus 5. And let me distribute x and then distribute negative 5. So when I distribute x, I get x cubed plus 8x squared plus 16x. And then when I distribute the negative 5, I get minus 5x squared minus 40x minus 80. Okay, and then combine the like terms. So we'll have x cubed, 8x squared minus 5x squared, that's 3x squared. 16x minus 40x, that's minus 24x, and then minus 80 at the end. Okay, so that'd be the answer. Okay, again, this problem is just like the previous two, only I don't have a graph, right? But they're telling me the zeros. So whenever I know a 0, I know a corresponding factor. Okay, now the term multiplicity just means how many times do I see the 0. So like I saw negative 4 twice. So I'm going to have x plus 4 times another x plus 4. Okay. Let's try problem 5 next. So in problem 5, it says for each polynomial function, find all the zeros and their multiplicities. Okay, so well, let's see. I need to find the zeros, so I need to find all the x values that will return 0. So if I set this equal to 0 and then solve, now the nice thing about this is that I'm already in a factored form. Okay, so I'm going to have x plus 7 squared equals 0, or x plus 7 equals 0. That's going to mean that x equals negative 7. Now, negative 7 is a 0 of multiplicity 2 because its factor is seen twice. Okay, by the way, when we have a 0 of multiplicity 1, we don't usually write that it has multiplicity 1, otherwise we're writing has multiplicity, for everything. So it's just only if you have an answer that repeats itself. Okay, so negative 7 is seen twice. 5x minus 2 equals 0. When you add 2 and divide by 5, x is 2/5. And then x squared minus 4 equals 0. Means that x squared is 4. So then when I take the square root of both sides, don't forget about the plus minus there. X would be plus or minus 2. Okay, and these numbers would be the zeros. Okay, I'm going to have, looks like 5 answers. Okay, so negative 7 is seen twice. I got negative 7 again, 2/5, 2, and negative 2. Okay. Let's try this one. So part B, we want to find the zeros for f of x equals 9x cubed plus 27x squared minus 2x minus 6. Okay. Now I'm going to show you a way to get the zeros, but don't forget about the techniques that you've already learned previous to this class. Like we should already know how to factor, right? Like factoring is not a new thing. Factoring by grouping is also something that we should know. Okay, so and that's how I'm going to do this problem. Let me let the first 2 terms be one group and the last 2 terms be another group. I want to find the zeros, so let's set f to be 0. and solve. Now, what's coming out of group 1 would be 9x squared. That would be in common to these two terms here. The leftover would be x plus 3. Now, to have the factor by grouping method work, I'm going to need another x plus 3 coming from group 2. If I can't get that, then I have to solve by using this other method that I'll talk about later. So if I factor out a negative 2 from these last two terms, that'll leave me with x plus 3. Okay, so when I distribute I get negative 2x minus 6, right? So x plus 3 is in common to these two groups here. Let's go ahead and factor that out of the whole thing. So the leftover from group 1 is 9x squared. The leftover from group 2 is a minus 2. Okay, and now if I set these two things equal to 0, x plus 3 equals 0, that means that x is negative 3. That would be one answer. And then 9x squared minus 2 equals 0. If you add 2 and divide by 9, you get x squared equals 2/9. So then take the square root of both sides. X would be plus or minus, don't forget about that. The square root of 2 divided by the square root of 9 is 3, right? So plus or minus root 2 over 3. Those would be the other two answers. So all in all, you have 3 answers. Okay, now one of the really important things that we're going to talk about here is what's called the fundamental theorem of algebra. Okay, the fundamental theorem of algebra is just a way to know how many answers you're going to have beforehand. If you just look at the degree of the polynomial, that will tell you how many answers there will be. Okay, so like before I even did this problem, I could already know that there's 3 answers. And here they are. They're negative 3, root 2 over 3, and then negative root 2 over 3. Those would be the 3 answers. Okay. All right, we'll start in on problem 6 in the next video there.